Ever wondered how your brain learns, grows, and changes throughout your life? The secret lies in cognitive development across the lifespan. This can help explain a lot, from how children learn to why memory and thought change as we age. It can also reveal how we shape our brain's future. When a baby plays with blocks, they grab and shake them to figure out what blocks are. Piaget called this the sensorimotor stage, a time when babies learn with their senses and actions. One key breakthrough here is object permanence, the knowledge that things exist even when out of sight. Games like Peekaboo help babies develop this skill and mark a huge step in how they think. For example, a baby might cry when a favorite toy is hidden, only to later search for it under a blanket once they've mastered this concept. Piaget's interest in cognitive development began during his work for Binet and Simon on early IQ tests. He noticed that children of similar ages often made the same kinds of mistakes, which led him to believe that their thought followed predictable patterns as they grew. He observed that younger children struggled with problems that involved conservation, like to determine whether two different shaped containers held the same amount of water. Born in Switzerland, Piaget trained as a biologist and philosopher, which helped him explore human thought with a unique scientific lens. As children grow, their thought becomes more complex. In the preoperational stage, they begin to use symbols, to pretend a banana is a phone, for instance. At this point, though, logic isn't their strength. A child might believe a taller glass holds more water than a shorter, wider one, even if the water levels are the same. This happens because they haven't yet grasped conservation, the idea that certain properties of objects don't change just because their appearance does. You might notice this stage in action if a child insists that a broken cookie is less than a whole one, even though both pieces add up to the same size. Later, in the concrete operational stage, kids start to solve these kinds of problems. They think with greater logic and recognize that concepts like conservation make sense. A child at this stage, for instance, would know that to rearrange a set of coins doesn't change their total value. However, their thought is still tied to what they can see and touch. Abstract or hypothetical ideas, like to imagine life on another planet, remain out of reach until the formal operational stage, where teens and adults can think broader and explore possibilities beyond the concrete. For example, a teenager in the formal operational stage might debate ethical questions, like whether it's better to save one life or sacrifice one to save many others. To Vygotsky, to learn was to be social. Children grow through interaction with others who guide them. A teacher might break tasks into manageable steps or provide hints to scaffold to help a child learn and thus help them operate within their zone of proximal development, the space between what they can do by themselves and what they can achieve with guidance. For example, a young child might struggle to solve a puzzle alone, but succeed when an adult encourages them to start with the edges. Vygotsky, born in Belarus, was influenced by the socio-political environment of the early Soviet Union. Taught by prominent scholars like Alexander Luria, his work was grounded in the quest to understand how culture shapes thought. Unlike Piaget, who emphasized stages of development, Vygotsky focused on the relationship between children and their social worlds. For example, to him, to learn a second language is not just about word memorization. It's also about adaptation to the cultural context in which those words are used, a Vygotskian perspective. These stages of cognitive development shape how we learn and solve problems. However, they're not the end of the story. Psychologist Raymond Cattell made a major contribution to understand this process. Cattell proposed that intelligence comes in two main forms: fluid intelligence and crystallized intelligence. Fluid intelligence is the ability to solve new problems, think fast, and adapt to unfamiliar situations. It's like the idea that you would build new roads to navigate unknown territory. For instance, a young coder who learns to program in Python for the first time uses fluid intelligence to grasp new concepts and debug their work. Crystallized intelligence, on the other hand, is the accumulated knowledge and skills we build over time. It's why older adults often excel at trivia or can remember long-forgotten facts with ease. They walk paths of experience. Think of a retired teacher who recalls the names of all US presidents in order, or a seasoned mechanic who diagnoses car trouble based on the sound of the engine. Cattell's research showed that fluid intelligence tends to peak in early adulthood and declines with age. However, crystallized intelligence can continue to grow, as it depends on what you learn, your culture, and your experience. His work also emphasized that to engage in mental challenges, even later in life, can help preserve cognitive abilities and counteract some of the decline in fluid intelligence. For instance, older adults who take up chess or learn a musical instrument can maintain their ability to strategize and problem solve, even as other abilities slow. What happens inside the brain to make all of this possible? Neurobiology provides some answers. The hippocampus, a structure located deep in the brain, is essential to form and retrieve memories. Processes like neurogenesis, the creation of new neurons, happen here throughout life, particularly when you challenge yourself mentally and physically. For example, exercise like a power lift or a run stimulates neurogenesis. Another process, long-term potentiation, strengthens connections between neurons, which allows the brain to consolidate what you learn and adapt to new experiences. This occurs when you practice a skill, like play scales on the piano or solve more complex math problems. Neurotransmitters play a central role. Dopamine, often called the motivation chemical, drives curiosity and focus, which helps you tackle new challenges, like learn how to solve a Rubik's Cube. Meanwhile, acetylcholine supports what you learn and memory to keep the brain flexible and sharp. It's critical for tasks like to remember directions to a new restaurant. On the flip side, stress can flood the brain with cortisol, which over time damages the hippocampus and slows neurogenesis. Imagine a student who crams all night for exams. Their stress might help in the short term, but prolonged stress can impair memory and what they learn over time. How do you handle stress in your daily life? Could small changes, like to take breaks or meditate, help protect your brain for the long term? Crystallized memories, ingrained pieces of knowledge, aren't just stored in the brain. The body remembers through skills and muscle memory. For example, someone who learned to ride a bike as a child can hop back on decades later without much effort, even if they haven't ridden in years. This shows how experience can embed itself within us. Even though the brain slows down over time in some ways, it doesn't mean we're powerless. Your brain is like a garden. Just as a gardener plants flowers, trims dead branches, and waters the soil to encourage growth, your brain thrives on care and attention. Processes like neurogenesis create new seeds of learning, while long-term potentiation makes sure those seeds take root and thrive. But what kind of gardener are you? How often do you water your brain with new challenges? And when was the last time you took a break to recover? For example, do you challenge yourself with hobbies like to cook a new recipe or play a new sport? Or do you allow your brain time to recharge with meditation? Even as fluid intelligence declines, we can take steps to slow this process. Challenge your brain progressively, allow time for recovery, and encourage adaptation to keep those neural pathways thriving. For example, to learn a new language gradually expands your brain's potential, while rest allows it to reorganize and strengthen these connections. Another concept to consider is compression of morbidity, the idea that healthy habits can shorten the period of decline at the end of life. For instance, centenarians in Okinawa, Japan often credit their long, healthy lives to social connection, daily physical activity like gardening, and a diet rich in vegetables and fish. Take care of your brain and body throughout life, through activities like exercise, proper nutrition, and mental engagement, and you can reduce the time spent in poor health. The way the brain evolves is a powerful reminder that cognitive development across the lifespan isn't just about early growth, it's a lifelong process. It's a chance to shape your future, one challenge and one recovery at a time. If we tend to our mental garden, engage in social thought, and embrace recovery and adaptation, we can grow stronger even as we age. So what will you do today to invest in your brain? Whether it's to solve a puzzle, go for a walk, or just take a moment to rest, the choices you make now create the foundation for a sharper, healthier mind tomorrow.